Okay, it's ongoing. And I hope that you all agree with the recording. All right. So we are here today um, for the qualifying examination or the qualifying doctoral qualifying of Vitor Maia of the System Engineering and Computer Science Department of Copy. Vitor Maia is working under the supervision of Guilherme Horta Travassos at Copy and Christoph Kolski and Katia Oliveira at the Université Polytechnique Hall de France. And he's a co-tutel student. And this presentation of the doctoral qualifying, it's a requirement of Copy. Okay. The committee that is going to evaluate the work of the proposal of Vitor, it's composed by me, Guilherme Horta Travassos, that's as a president of the committee, Christoph Kolsk and Katia Marçal de Oliveira, the advisors at Polytechnique Hall de France. And the referees are going to be Paulo Pires from the Federal University of Niterói, Fluminense in Niterói, Professor Sophie Lepreux, the Polytechnique Hall de France, and Cláudio Miceli de Farias from COPI, Federal University of Rio de Janeiro. Vitor, you have about 40 minutes to present your proposal. And after that, all the referees are going to use your roundtable style to agree you and then discuss your proposal. Okay? I would like to kindly ask all of you to keep your mics off. All right? And the committee, if you want, you can keep the video on or off. It doesn't matter. All right? Thank you. Go ahead.
Guilherme,
Yes.
are you recording? Because I don't see this
Yes,
information.
because I'm using OBS. It's outside the system.
Okay.
All right? Okay.
Okay. 1 minute. Just tell me if you are seeing the full screen. Is it okay?
It's fine for me, but it's not in presentation mode yet.
I see. I do differently. Maybe now.
Yes,
Is it fine?
much better. Okay.
Much better. And can you see my pointer and my mouse?
Yes, always working for me.
Okay, so I start. Thank you very much for being here today. I'm Vitor Maia. I'm a Cototel PhD student between Brazil and France, Universidade Federal do Rio de Janeiro and Université Polytechnique de France. And the title of my work is Contribution to the Internet of Things through Design and Evaluation of Context-Aware Interactive Systems for Locating, Using, and Managing Objects in Socio-Technical Environments. These are the contents of my presentation. I will start by talking about my motivation, problem, goal, and methodology, and then I follow by explaining the two first steps of my methodology. So, Copy in Brazil has a partnership with Fiocruz. Fiocruz is a research and development medical institution in Brazil, and together with Copy, they have, for a long time, several medical projects. They are involved in projects together. And during the pandemics, Fiocruz reported a difficulty to Copy. They were having a hard time trying to locate objects inside hospitals. And sometimes it's serious because in case of an emergency, some objects, some medical equipment should be located quickly in order to save the life of a patient. And these objects should not only be found, but they should be in conditions to be used. For example, they should be clean, they must not be broken. And they were facing these two difficulties altogether, especially during the pandemics. This problem usually exists in normal settings, but it was especially serious during the pandemics. I was motivated by these two difficulties of locating and managing the objects. However, even though I am motivated by the context of health centers, I am stepping up. I am thinking about socio-technical environments. In fact, I took a look in literature for this problem to see if it existed in other places. And I noticed that it exists in industry, in supply chain, in offices. So it's a broader problem. It do not belong only to health centers. So even though, as I said, motivated by this context, I am thinking a little more generically. I'm thinking in terms of social technical environments. And I also have a secondary motivation. When possible, if possible, I'd like to avoid disturbing the working routines of people, of users. For example, it would be very interesting if there exists a system in a hospital to locate and manage objects, but the nurses and the physicians could keep working without being bothered. I would like, when possible, to reduce explicit interactions to fulfill this secondary requirement. Coming to my research question, how to support the engineering of interactive IoT software systems for locating, using, and managing objects considering social technical environment constraints and minimal explicit human-computer interaction. But what do I mean by locating, using, and managing? This is my scope. That's what I am talking about. Locating is understanding where an object is within a restricted area and within a small margin of error, making use of an object for a particular purpose, and managing, keeping track of objects, location, and individual states, such as being available in use, dirty, damaged. So when I use the verb to manage, that's what I'm talking about. I'm talking about the states of an object and where it is. My goal is to define a conceptual model to orchestrate hardware and software for interactive IoT software systems, engineering, and social technical environments. But what do I mean by orchestration here? I am thinking generically. I'd like to propose a solution for locating objects in a specific social technical environment. So I will receive the requirements of this specific environment. And depending on these requirements, some hardware and some software couldn't or shouldn't be used. I may not use a certain wireless technology in a certain environment, so I need to orchestrate. That's what I am talking about. And I can break this goal in some objectives, in three objectives. First, I'd like to propose a context awareness meta model. In this model, I will represent the objects which I wish to locate and manage, but also the users in this environment, the environment itself, the locations, and the technologies which will be implemented together. And by representing user, the environment, and the technology, I am talking about context awareness. Apart from, of course, other entities which will appear. Also, by composing an instantiation process. The objective of this process is to receive requirements of a specific location and apply it to the meta model and deliver specifications for making a system, for locating objects in that specific environment. And finally, performing proofs of concept. I intend to do two for health centers, one here in France and another in Brazil. I talk about my methodology now, divided in three phases. I'm showing now only the first one, the conception phase. Here in the conception phase, my objective is to obtain knowledge about locating, about IoT technologies, compare them, go a little further in some of them, like NFC or RFID. The second one, development phase. It's here that I will make the meta model and the instantiation process. Notice that I am making a loop. That's because I understand that by making one version of the meta model will permit me to make a first version of the instantiation process. But by applying the instantiation process, by testing it, I will notice problems in the meta model. So I understand that I will be here in loop for some time. And when I am finally happy with a version of the meta model and of the instantiation process, I will go to the feasibility phase, in which I will apply them for implementing a system first for a French hospital here, followed by an evaluation. And then when I return to Brazil, I'll do the same thing in Brazil, make an evaluation, making an implementation of a system for a Brazilian hospital, followed by an evaluation. And I understand that here, also during the whole feasibility phase, I will need to return to the development phase sometimes to keep polishing the meta model and the essential process, especially now that I will be in a real situation. That's what I have what I did by now. I performed an analysis of IT technologies. I compared some of them, and then I made a systematic mapping about the adoption of RFID interactive systems. Now I am designing the meta model. I have a first version. And while making this first version, I felt the necessity of making an additional research about location, about locating objects indoors, generically. I didn't do it before, so I'm doing both in parallel, one in the conception phase and another in the development phase. So entering the conception phase, first state of art. Of course, in literature, we find many papers about locating objects. But as far as I know, I don't know studies with some of these approaches here. I wish to make objects talk with themselves, exchange information. For example, I'd like that an object knows about the states of other objects of interest to exchange information and, for example, an object be able to recommend the use of another object because itself is old or is broken. This idea of managing the states of objects, I don't seem to find it in papers too. And also the generic representation, which I intend to do with the meta model, I don't see it in papers for the location and managing of objects. Concerning health centers, usually implementation of system for location is for locating patients. In most cases, it's for locating patients, sometimes staff, and usually not objects. When it comes to objects, it's only to locate and identify medicines. It may be because some radio frequencies cause electromagnetic interference in some electric medical equipment. It may be the reason for not using so many radio frequency technologies in hospitals. I'll start by in the conception phase. I made 3 researches. I start by talking about the location of objects indoors. I performed a structural review for characterizing the location of objects indoors. In the selected papers, I was looking for technologies to achieve that, techniques, methods. And for that, I made a search string, a PyCork search string. I'll show it in the next slide. It was executed in the beginning of the last month because, as I said, while presenting the methodology, it was done out of order. Starting by nearly 1,000 papers, I selected 51, found 38, but I didn't read all these 38. I manually selected 6 of them, which were secondary studies, and which seemed to be the most interesting among these 38. So I only analyzed these six papers. This is the search string I used with a comprehensive population and a comprehensive context, but my intervention was just location and the outcome was just a review. And I came to this representation here. For identifying indoors, I can use an inertia approach by using movement sensors, for example. I can use visible light or infrared. I can use cameras for computer vision analysis, acoustic solutions such as ultrasound and radar. and several radio frequencies wireless technologies such as RFID, Wi-Fi, Bluetooth, ultra-wideband. Now, this on the research I did, chronologically was the first one I did, in fact. And my objective here was to get in touch with the technologies for identification, location, and communication. I'm interested in locating, but I need to know what I am locating, that's identification, and I need to send information to a broker or a server. So I need to look for communication technologies as well. And it was not an extensive research, it was ad hoc. I looked in papers I already knew about and made a comparison of technologies, several technologies. This first table shows the identification technologies in terms of some features. I did it here for identification, here for location technologies. The list is a little different, and also for communication technologies. Here I am including the max range, for example. I am comparing with some different features. And this quick research, this ad hoc research, made me notice that the passive ultra-high frequency RFID seemed to be an interesting option to be adopted as a main technology in the meta model, because it can uniquely identify an object. It reads around 5 meters, so I could use a reader to read every tag in a room. Tags are not expensive, passive tags don't need batteries, so it seemed to be an interesting option. And I wondered, could we adopt RFID as a main technology for our solutions? To answer this question, I went to a new research, this time a robust, systematic mapping about the adoption of RFID. This was my goal, to characterize the adoption of RFID in interactive software systems, in the point of view of software developers and designers, with respect to several issues which I will talk in the next slide. Here, I hope you can see well. Here is the protocol of the systematic mapping, my search string up here. The population and the context are exactly the same I used for the previous review I talked about locating. But my intervention is radio frequency identification and variations. My research questions, what I am interested in papers. I only selected papers which described an implementation, a system, a project which adopted RFID to locate people or objects. I wanted to know from these papers, which was the problem domain of these projects, why RFID was adopted instead of other technology, who was interacting with RFID and how, which were the restrictions, the requirements related to the implementation of RFID in these systems, and what about quality characteristics, which are related, and does it have any important measures? I executed it in July last year. I got nearly 500 papers. I read 85. By applying exclusion criteria and quality assessment, I reduced it to 53. And by applying snowballing, I added 6 more papers. I ended up with a set of 59 papers to be analyzed. I will not talk about all the results, only some of them. Those which I think that are the most interesting. The most frequent problem domains were medical, supply chain, home automation, and road traffic solutions, among some others. And in consonance with this list of main problem domains, who interacts, considering human users and objects interacting with RFID. The humans are patients, residents, and drivers, and the objects are products in supply chain and also vehicles. And how is the interaction? It's mainly implicit. Almost every paper was describing RFID being used in an implicit way. What do I mean by implicit? A user carries a card, but the user is not touching the card anywhere. For example, the system constantly checks tags and allocation to make an interpretation. When it came to explicit interactions, it was usually approximating a card, a necklace, a bracelet. It was usually approximating, in fact, but in most cases, the system was not like that. The systems were using ultra high frequency. In restrictions, I got many results here. I separated restrictions into characteristics, requirements, and limitations. By characteristics, I mean the architecture of RFID, having several frequencies, and so on. Requirements were decisions related to a specific problem domain. And limitations are the bad characteristics, something that hinders the utilization. I have a small list here, but I wish to highlight the last one. Ultra-high frequency RFID causes interference in some electrical medical equipment. Until this point, I didn't know about it. I learned it while making this research. And what did I learn here? Can I adopt RFID as a main technology for all the solutions? No, I can't. Because depending on the environment, I shouldn't use a technology because other technology is more suitable. Concerning health centers, I can only use ultra-high frequency RFID in health centers which, for sure, don't have equipment which are affected by electromagnetic interference. Entering now to the development phase. That's the first version, the preliminary version of the meta model. Here I am representing in blue the object, and in green the environment, the user, and the technology. The technology has a ubiquity level property. I intend to use this property to rank how much explicit interactions are necessary to use each of these technologies. I intend to use this information to reduce the explicit interactions in a proposed solution in the future by the process. I will quickly explain some of the entities here. The technologies may be for identification, for location, or for communication. The objects are used by a user. The users will possess none or many of them. And the objects are used for performing a task. And users may have one or several roles, and depending on the role, that role performs a task. The task is performed in a room, and the objects may be in a room, but maybe from another room. If the object is in the correct room, they are in a room and they are from the same room. That's how I will notice that they are in the correct location. The environment contains the rules of that environment, such as the rules of a hospital, the rules of an industry, and the whole model must obey the rules of the environment. And inside this environment, I have several rooms and some routes. I'm calling a route a sequence of rooms, such as going from one place to another. I am representing devices as well. Devices are a kind of object, but which are there for helping the implementation of the system, such as mobile phones, dashboards for presenting, for displaying information, microcontrollers attached to sensors, RFID readers, tags. What more? Oh, yes. The object has traits. Depending on the traits of an object, a technology may be suitable or not. For example, if an object is affected by electromagnetic interference, it would be a trait. So RFID, ultra-high frequency RFID, can't be an implemented technology. And I am implementing technology in the user and in device. The device, because the device are part of the technology as well, but also users, because depending on the solution, it may be necessary to identify and locate the users as well, such as to know which user is using a certain object and where the user is. let me go back. There are the states here below the traits. The states are, for example, being stray, being dirty, being broken. These are the states of the object. The object may have more than one state, depending on the class, depending on the complexity of this object. And I will represent it by means of a life cycle. This is a very simplified life cycle, simplified and generic, which represents an object, the states of an object since its acquisition until its disposal. I am representing if it is in use, if it's stray, if it's corrupted, broken. And to change the state of an object, there must be an interaction made by the system or made by a user, which may be proper or improper. Depending on the class of object, this life cycle will be different. And I understand that most of the real life cycles will be very complex, much more than this one. I didn't start making the translation process yet, but how will it work? I will have a version of the meta model, the most recent version of the meta model, and it will receive as input the requirements of a specific location, of a specific socio-technical environment. These requirements will be applied to the meta model, and I will deliver implementations, but I don't intend to deliver code, the implemented system. No. If
Hello?
given I will, first of all, adapt object diagrams as much as possible to facilitate the implementations. But it's not done yet. I'd like to give you one example, a very simple example. I'm considering a hospital with only 3 rooms, room A, room B, and room C. In this hospital, I have as staff only nurses and physicians. The objects here are stethoscopes and wheelchairs. I selected these 2 because they are not affected by electromagnetic interference, just to facilitate the example. And as I said, 3 rooms. And in this case, it is necessary to locate the users, not only the objects, but also the users. In this case, given this list of characteristics of this hospital, it would be possible to implement with ultra-high frequency RFID. For example, the instantiation process would recommend a solution using this technology by analyzing the traits of these 2 objects. What's happening here in my example? Room A and Room B, both of them have RFID readers to read ultra-high frequency tags. And this stethoscope here belongs to room A. When the RFID reader from room A reads the presence of this stethoscope here, it seems that it's fine. This object is in the proper place. But one day, a nurse goes to room A and takes this object because she needs to use it in room B. So the nurse goes there, takes the object, and leaves, and that's all. She's living her life, and it's not. She's ignoring that is a system in this hospital. Immediately, the reader in room A will notice that the stethoscope, which was there moments ago, is not there anymore. And moments before, this reader also read the identification card of the nurse. So maybe the nurse took this object and left. The reader is not sure, but this information is sent, for example, by using Bluetooth to a broker. Here I am representing Bluetooth, but it could be Wi-Fi, for example. It's just to communicate the information. When the nurse reaches room B, the reader in room B will notice the presence of the stethoscope and also of the nurse. This information is sent to the broker, and by fusing these two informations, the broker will deduce that this specific nurse is using this specific stethoscope. And this information will be displayed in a dashboard in room C. This application in this dashboard would display only where are the objects which are out of place and which are the staff using them in that moment. Here I am adapting the meta model, the first version of the meta model, and notice that in the previous version of the meta model, I had several technologies down here. But now I am representing on only RFID and only Bluetooth. The instantiation process would do that. It's not necessary to represent Wi-Fi, NFC, if I will not use in this system. I am reducing classes and I am also adding classes because originally I only have an object class, but I have in this example stethoscopes and wheelchairs. Even though I am not talking about wheelchairs, there are some there as well. The possible roles here in this hospital are physician and nursing, which will perform tasks. Probably the physician will make consultations and the nurses will make attendances. This room may have several types of rooms, such as storages and lobby. And hospital is the environment itself. So based on a list of requirements, I'd like to, first of all, adapt the meta model. And in addition, propose several other possibilities. If I am aware of the actions happening in this socio-technical environment, I can, for example, propose activity and use cases diagram as well. And that's it. Here I am listing my next steps, starting next month until my defense. And by now, I am working on the design of the model. And as soon as possible, I think that maybe in January, I will start thinking in the process. And as soon as possible, too, I think that in February, I will start making an implementation of a system for a French hospital. Also in January, I intend to submit some papers to CAI and Interact. The evaluation of this first system may happen in May and may happen until July. And during this whole time here, not only in August, I think that I will keep polishing the model and process constantly. I return to Brazil in October, and as soon as I return, I will do the same thing in Brazil. Organize the implementation of a system for a Brazilian hospital, followed again by an evaluation of the second system. In February 2024, I will start writing the thesis. I will do it until May. And from June to August, I will follow the procedures for defense in both universities, in France and in Brazil. Finally, I intend to defend in September. And that's it. Thank you very much.
Okay, Vitor, thank you so much for the presentation in a good time. So you can stop sharing the screen, please. If
Okay.
you need to come back to the slides, you can obviously open it again. So I will stop the recording now.